So the end part of this 5.1 is kind of the tricky bit. So we all know how tricky zeros and ones and negatives can be, and this is exactly what is going on here. Well, maybe not the zero, but the -1 as a factor is the key to understanding these ones. So these ones are ones to watch for. They do kind of illustrate the first symptoms you might experience in this chapter. Another instructor calls it cancelitis, where you get so intoxicated by crossing out large parts of your question that you get a little too happy on that. So let's take a look at A, and I'm going to allow us to kind of walk into this problem. Maybe have our first taste of cancelitis. So for A, when I take a look at factoring the top part of that rational expression, I can see that I have a 2 common to them, and I'd have an x minus 2 then. On the bottom part here, I could take a look at it and I would see a difference of squares. And so I would write it out as 2 plus x and 2 minus x. If you are inclined to cross out this x minus 2 and this 2 minus x, you may have cancelitis because they're not exactly the same. So the thing with this is that this is what we're going to focus on. And I'm going to do some work over here. And the thing I'm going to do, sometimes it's nice to write some notes, I'm going to put in descending order. And if I were to do that, I would put the x term first and the whole number out the end. There you can see that it's almost the same as this bracket on the top, but it's not exactly the same. We're going to monkey with this and we're going to factor out a -1. And so if I factor out this -1, I'd write -1 as my factor out the front. And in the brackets, I'd fill those up with what was left over if I divided by -1. And so that would leave me with an x minus 2. So I'm going to take this and replace this bracket that I was monkeying with, because now I have engineered it so that I do have brackets that match. And I'm just replacing this bracket with all my work from over here. So I'd have a -1 and I'd have an x minus 2. So now you can see what is exactly the same. Now we could cross these out. The only difference is that I have this -1 here. So for my final answer, kind of like when we were dealing with fractions before, doesn't matter where that -1 or that negative sign is, your final answer would be a -2 over 2 plus x. And if you want, that negative can go with the top, that negative can go with the bottom. You could leave it here in the brackets. That's all cool. So that would be your final answer in the back of the book. Let's take a look at the next one here. So it's going to be similar, and sometimes it's worth kind of following this through a couple ways. I think it is also worthwhile showing your work outside of the question. So stepping into these, we're going to try and factor and reduce, and hopefully not display any cancelitis symptoms in the process. So we've got the top part of this rational expression. Common factor would be a 3, and factoring that out, I'd be left with an x minus 3. The bottom, again, is a difference of squares. I would have a positive one bracket, a negative in the other. And factoring that difference of squares, I'd be left with 3 plus x and a 3 minus x. Now, here is where the cancelitis comes in. This x minus 3 and the 3 minus x look really, really close. We're going to monkey with this to see if we can make them match with this idea of factoring a -1 out to make those brackets match. So I'm going to start with this and write it in descending order. So that's the same as -x plus 3. Good old commutative property of addition here. If I factor a -1 out, that switches the signs. If you want to show your work, you can. That's going to give me an x minus 3. So now rewriting this back in place so I can see that I have my brackets matching. You could rewrite it like that. Or now that whoops, I copied that wrong. That whole point of that was that it was x minus 3. Sorry about that. X minus 3. Now those match and I could cancel those out. Your final answer, you could put that negative anywhere. It could stay down below. It could go with the 3. It could go out in front. So I'm going to be hopefully the least confusing with it and write it out the front. The last two here, oh, one more note on this. In the back of the book, they might have corrected the denominator of this rational expression to put it in descending order. It's fine no matter which way you do it, because we know we have that associative property of addition. Okay, the bottom two involve this kind of idea where you have to make the brackets match by factoring a -1 out. They also involve some trinomial factoring. They are shortcut trinomials, and so I'm going to throw the answers up for these ones, but I then will go through how to get there. Give these ones a shot in class or on your own and double check your work. That's a bit messy. And that negative should be out in front of that one. Okay, showing my work on these, the top part of this rational expression would be a 3 plus x and a 3 minus x. The bottom part would be an AC test with -15 at the top. It's a shortcuttable one because of that 1 out the front. So 1, 15, 3, and 5. If I go with a -3 and a +5, that's what adds together to give me my +2, my B term. So my binomials would be x minus 3 and an x plus 5. And here I can see that I have this bracket that's not in descending order. That's your first clue, and it's really close to this one down here. So I'm going to take that one out and do some rough work on it. So I'd have -x plus 3, writing it in descending order, and then showing my work, factoring that -1 out. You can drop showing your work. I just find that for these four, I show it every time because, yeah, some people need it for sure. So I get x minus 3 in factored form. So putting it back in place, and -1 and x minus 3. So that's the top fully monkeyed with. And then this really satisfying thing where you can cross those out. And for this answer, I took that -1 and put the negative out in front of my fraction. Last one here. I've got a trinomial on the top. I have -27 at the top of my trinomial. It's a simple trinomial, so I can use my shortcut. I'd have 1 and 27, 3 and 9. It's going to be a +3 and a -9 for that one. So that's what can, add to -6. It's also the numbers in my binomials. So factoring the top, I'd have an x plus 3 and an x minus 9. On the bottom, I have this difference of squares. And now I have this bracket that I'm going to take my attention and factor out that -1. I write it in descending order so I can see it for what it's really worth and factor that -1 out. Again, showing my work shows how I can alter the way it looks without changing the value. So rewriting everything now in factored form. And if you want, you can switch those two around. My answer has them switched around. So x plus 9 and a -1, that's a plus, and an x minus 9. You get to this really satisfying step of crossing those two out to get to your final answer. And again, that negative is out in front of the whole thing. It might be worth putting in those brackets if your writing was as messy as mine in this section.